And a warm welcome to Dr. Chanchala Jain ma'am for the 7-day FDP training program on first-hand experience on SPSS Introductory Module, jointly organized by Parul University and Research Foundation of India. Ma'am, you can start the day 3 session, ma'am. Thank you.
Thank you, Renuka ma'am. Give me a second, ma'am. I need to share the sheets with sir so that we can share these sheets with the participants.
Yes, ma'am. Sure, ma'am.
Yeah. Ajay sir?
Yes, ma'am.
Sir, I have shared one sheet with you for
Okay.
today's practice. Please share with the participants.
Yes, ma'am. I
Yes.
share in good. Yeah.
Yeah, thank you so much, sir. So good evening, everyone. I'm back again with the third day session. Today I'm going to discuss, as per the schedule, today I'm going to discuss chi-square test. So give me a second, I'm sharing my screen. Can anyone confirm my screen is visible or not?
Yes, ma'am, it's visible.
Yeah, thank you.
Yes, ma'am.
Thank you, sir. Thank you, ma'am. So today I'm going to discuss the chi-square test using SPSS. In my first day session, I think I have talked about I had word with all of you regarding the parametric test and non-parametric test. So can any one of you tell me which type of test is chi-square test?
Non-parametric.
It's a non-parametric test. Yes, sir. In many a situation, we are considering chi-square test as a non-parametric test. I think in the first day session, I have also discussed about the meaning of the non-parametric test. So tests which are distribution free, which are not depending upon the normal distribution, generally we are considering those tests as non-parametric tests. So in the non-parametric test category, we can keep one of the tests we can keep as chi-square test. So question comes, when to use non-parametric tests? So the answer is when we are measuring our variable on nominal scale or ordinal scale. In that case, we can go for the non-parametric test. Then second condition is the sample sizes of the study groups are unequal. For the chi-square, the groups may be of equal size or unequal size, whereas some parametric tests required groups of equal or approximately equal size. So in many a parametric tests, generally, some of the parametric tests are requiring that if we are having certain levels in any particular variable, so there should be generally the same group size should be there. But non-parametric test is robust against this particular assumption. And if we have non-equal, or I can say when we have the groups with the unequal sizes, even then we can go for the chi-square test. Now, in case of parametric tests, there are certain assumptions for each and every test. And one of the major assumptions in those tests is that the variable which we are measuring on interval scale or on ratio scale, it should be measured on, it should follow the normal distribution. So if this condition is not followed by the variable, in that case, what we need to do, we can go for the non-parametric test. So what can be the assumption for parametric test? One assumption, as I just said, if the distribution is having the serious skewness, or it is seriously skewed or kurtotic, in that case, we will not go for the parametric test. And in place of parametric test, we will go for the non-parametric test. So parametric test generally assumes the normal distribution of the dependent variable or the variable which we are measuring on continuous scale. So in that case, if continuous scale variable is not following the normal distribution, or it is skewed, or it is kurtotic, in that case we will not go for the parametric test, and we will select the test appropriate in the category of non-parametric test. Then the data violate the assumptions of equal variance or homoscedasticity. That means in parametric test, one assumption is generally that the groups which we are having in the dependent variable or in the continuous variable, they should have the equal variance, or those groups should have the equal variance, or they should be homoscedastic. So if this assumption is again violated by the data, in that case again we will go for the non-parametric test. So for any further number of reasons, the continuous data were collapsed into some smaller number of categories. Thus, the data are no longer the interval or ratio scale data. Means if in continuous variable, there is certain different categories available. So in that case, we will not go for the parametric test, and we will select the non-parametric test. Say for example, maybe you have heard about factor analysis, I think, and so many of you have also applied factor analysis also. So when we are going for the factor analysis, so what we are doing, we are trying to find the factors of any particular construct. Say for example, there is a particular construct named as service quality. This service quality scale is given by the Persuman and their colleague, and his colleagues. So in that particular scale, generally there are certain dimensions of service quality, like tangibility, responsiveness, etc., reliability, etc. So in that case, for each and every category, if we are getting a smaller number of responses, so might be possible we will not go for the parametric test, and then we can select the non-parametric test. So these are the certain reasons, these are the certain things which we need to keep in our mind to opt for the non-parametric test. That means if we have a data on the continuous scale, that is on the interval scale or on the ratio scale, still for that kind of data we can go for the non-parametric test if data is violating the assumptions of particular parametric test. And few of the assumptions I have just discussed. One is the normal distribution, and second one is the uh, equal variance or homogeneity of variance among the groups of any variable. So if these assumptions are not followed by the variable, we will go for the non-parametric test. So these were the certain things we need to keep in our mind while selecting the non-parametric test. Talking about chi-square test today, as I have to discuss this. So firstly, I'm telling you what is chi-square test, and then we'll go in SPSS, and then we will see how we can apply chi-square test. So chi-square test, known as Pearson's chi-square test, because it is given by the Pearson. So that's why we are also knowing this test as Pearson's chi-square test. It is also known as the distribution free test or non-parametric test. Generally, when we need to find the association between the two nominal or ordinal scale variable, in that case, we can opt for the chi-square test. Then, generally, whenever we are interested to find the difference in the frequencies, in the observed frequencies and in the expected frequency, in that case also, we can go for the chi-square test. Because generally the parametric tests are concerned with the quantitative data, but chi-square or non-parametric tests can also be applied on the qualitative type of data. Say for example, if we have only numbers, that means frequencies we are having only. So in that case also we can go for the non-parametric test, and for the frequencies the appropriate test is the chi-square test. So it is used to measure significant difference between the observed and the expected frequencies. So I think, am I clear till this particular point, and my pace is okay for a day?
Yes, ma'am.
Yeah. Now, two important things to note when we are going for the chi-square test. The first one, chi-square only tests whether two individual variables are independent in binary format. That means whenever we have data for in the binary format or in the dichotomous scale format, in that case we will go for the chi-square test. And for both the variable, we are interested to see, or we are interested to find this thing, that whether the variables are independent to each other or not, or we can say we are interested to see, or we are interested to find whether there is any association between those two variables or not. Then chi-square requires researchers to use numerical values, also known as frequency counts instead of using percentage. Means if we have data in the frequency form or in the numerical values form, in that case we will go for the chi-square test. But suppose if we have data in the percentage form, in that case chi-square not is the appropriate test to apply on. So these two things again we need to keep in our mind while going for the chi-square test. So null hypothesis for chi-square test we can make as there is no relationship between two categorical variables, or there is no association between two categorical variables. So if you know the value of one variable, it does not help you to predict the value of another variable. That means whenever I think maybe we are knowing about the correlation also, generally correlation is also used, we are also using correlation for finding the relationship between two variables. And further, if there is a relationship exists between two variables, then further we will go for the regression. And with the help of regression, we are trying to predict the value of one variable. We are trying to predict the value of one variable by using or by keeping the value of the other variable. So this is what we do in the correlation and regression. But here also we are interested in finding the relationship or association between the two variables. So it does not mean that we are interested to predict one variable on the basis of the other variable, because chi-square test has not that type of nature, or we can say it has not that type of capacity that will allow us to predict the categorical variable on the basis on the value of the on the basis of the value of the another categorical variable. So this is the important thing again we need to think upon. Now, say for example, being a researchers, being a statistician, suppose we have certain questions. Here I have taken one example. Suppose we want to measure whether there is an association between reader's choice and magazine type. So this is what question, suppose it comes in my mind. So this particular question can also be formulated in the second way, that is whether reader's choice is related to magazine type, or I can say whether reader's choice is dependent on magazine type. So in these three different questions, all three questions are saying us the same thing, that we are interested to find whether there is any link between the magazine type and the reader's choice or not. So for these different formulated type of questions, we can make the three different type of hypothesis for chi-square test. So for the first question, that is whether there is an association between reader's choice and magazine type, our hypothesis will be there is no association between magazine type and reader's choice. Now, second question I have formulated, that means I want to find whether reader's choice is related to magazine type. So for this particular question, I can make my hypothesis reader's choice is not related to magazine type. Lastly, for the third question, whether reader's choice is dependent on magazine type, I can formulate my hypothesis as reader's choice is independent of magazine type. So friends, this way, for these three questions, because all three are stating us almost similar meaning, so for these three questions, we can make these three types of hypothesis. And here, both the variables which we are considering, that is the reader's choice and the magazine type, we can say both are the kind of nominal scale variable, and thus I can go for the chi-square test because nominal scale comes under the categorical scale category, and for chi-square test we should have two categorical variables. So according to this particular hypothesis, we can come to this conclusion that we can go for the chi-square test because we are interested in finding the association between the two categorical variables. Now, for this particular hypothesis example, suppose this is the data we have. So here we have the magazine type and the reader's choice, or the number of readers who are reading these different magazines. So here I can go for this type of hypothesis testing. So magazine type, you can see we are having, suppose, business and finance type of magazine, cooking and food type of magazine, entertainment type of magazine. So 75 of the readers are interested to read business and finance. Then 58 readers are interested to read cooking and food type of magazine, and 67 readers are interested to read entertainment type of magazine. So that way we have total 200 readers, and we have classified these readers on the basis of their magazine type. So further, you can see maybe from this particular table which I have just shown you, in that you can see example and the magazine type and the reader's choice is mentioned. So from this I am picking only one category, that is cooking and food. So for this also we can make one more hypothesis. If we want to find whether we are interested in finding that females prefer cooking and food magazine more than males. So here I have asked this question, suppose, from the respondents. In those respondents, there are male also and there are females also. So that way I can say I am interested in this particular hypothesis testing. So I have asked this question from the respondents. So here we can see out of 33 males, 12 says that they are interested in reading the cooking and food type of magazine, and 21 are saying to us that they are not interested in reading such kind of magazine. Then out of 82, 68 of the females are saying yes, they are interested in reading this type of magazine, and 14 of the females are saying that they are not interested in reading such kind of magazine. So friends, this way you can see we have total 115 respondents data that we have classified in the male and female category on the basis of their choices for cooking and food magazine. So this type of tabulation of the data, we can call it as a contingency table. So in the chi-square test, generally contingency table is used. Now, as I just told you in the previous slides, I have just discussed all these things, that whenever we have a data in the frequencies form, and when the variables are measured on nominal or ordinal scale, so we will go for the chi-square test. And generally, with the help of chi-square test, we are interested to find the relationship between the categorical variables. So I think, am I clear till this particular point?
Yes, ma'am.
Yeah.
Yes, ma'am.
Thank you, ma'am. Now, as I said at the first day, in statistics, almost for each and every test, there are certain assumptions. So thus, with the chi-square test also, we have certain assumptions. The very first assumption of chi-square test is individual observations should be independent of each other. So the meaning of this particular assumption is that means we need to collect data from one respondent only once. That means only one time I need to collect the data from the one respondent. I do not need to repeat the same respondent. Means, for example, sometimes it happens what we do for the saking of completion or for the saking of meeting the sample size, whatever we have prescribed in our research paper or in our research study. Generally, we do these type of malpractices. We generally circulate our questionnaire to the same people 2 and 3 times, and that might be possible we are getting the responses of one respondent 2 or 3 times. So that way, in that case, this particular assumption will be violated. So we need to collect data from the one respondent only once. So that way, this assumption will be meeting. Second, expected cell frequencies should not be too small. That is, expected cell count should not be less than 5 in 20% of cells. So whatever number of cells will be there for the expected frequencies, in that 20% on those cells, 20% of these cells should not carry expected frequency less than 5. That means there should not be less than 5 observations in each expected cell for the 20% of the cells of the expected count. I think might be possible some of you are feeling little bit what I can say problem in understanding this particular assumption. If you are feeling this problem, so when I'll go to the SPSS, I think that we would be very much clear about understanding this second assumption of the chi-square test. So as a thumb rule, chi-square should not be used if more than 20% of the expected frequencies have value less than 5. So for example, if I have 5 expected cell count, that means what is the 20% of 5? What will be what is the value of 20% of 5 cells?
1.
1. Very good. So that means at least in one cell, if in one cell there is a expected count less than 5, we will find with it. If suppose in more than one cell expected count is less than 5, that means this is the violation of the assumption of Pearson's chi-square test. In that case, we will not go for chi-square test. I think now I am making sense. Is it clear now? Yes.
Yes, ma'am.
Yeah. Thank you so much, ma'am. Now, as I just said, contingency table. So,
Yes. Yeah.
any
I have this query. If you can share sheets where you can explain to us in which conditions we are not supposed to use chi-square test, and in which condition our criteria fulfills for the chi-square test. If you can share it with the example of sheets, the data.
I think, sir, when we will go in SPSS, I'll tell you how to apply chi-square test. In that, I'll tell you the assumptions also. So with those examples,
Sure.
you can understand that the assumptions are meeting or not. Are you getting me? I think this is
Sure.
what your question is.
Yeah.
Yeah. Thank you, sir. So I think I have shared a sheet with all of you. So we will perform the chi-square test in that particular sheet along with the assumptions. And then I'll explain you again whether we are meeting with the assumptions or not. Okay, sir, it's fine. Yeah. So I think I have just discussed about the contingency table. So I have taken one slide here also for the contingency table. This is a cross table or two-way table. That means you used to show one variable in row and other variable in column with their frequencies. And this type of frequency distribution of the data is of the categorical variable is known as the contingency table. So again, I'll repeat, it would be generally 2 by 2 table. In that, it is not 2 by 2, it can be more than what I can say, more than 2 by 2 also, but always there would be columns and rows, and in we are keeping one variable in rows and second variable in column, and then whatever frequencies we are getting with the help of the respondents data, we will keep that particular respondent data according to row and column combination, and this particular combination or table is known as the contingency table. Now, to understand contingency table, I have taken one example here. Suppose a researcher wants to measure popularity of film stars between males and females. So in that case, you can see here, I have taken the name of the 5 film stars: Hrithik Roshan, Ranveer Singh, Salman Khan, Shah Rukh Khan, and Amir Khan. And these are the number of fans, male and female fans are there. And these are the total, means this is the row wise total and this is the column wise total. So that way I can say, if I want to see the fan following for the Hrithik Roshan, so you can say total 70 fans are the fan of the Hrithik Roshan. Similarly, if I want to find how many males are or how many males are the fan of the film stars, that way you can see 150 are the male fans who are liking these stars, and again 150 are the females who are liking these film stars. So that way we can say this is the data of total 300 people. So for this type of data, we can frame our hypothesis as there is no significant difference between number of male and female fans, just a minute, male and female fans for various film stars. So other way of making this particular hypothesis can be that the popularity of film stars is independent of gender. So that can also means we can formulate the hypothesis in that way also. Although I have not mentioned this hypothesis in slide, but also we can write the hypothesis as that the popularity of the film stars is independent of gender. So for this kind of data, we can go for the chi-square test. So I think we all have studied chi-square manually. This is the formula I am showing you. We are representing chi-square like this. This is the Greek word. I think this is the Greek word we are using to represent chi-square. Formula is summation O minus E square divided by E, or we can also write FO minus FE square divided by FE. Sum of all these quantities or all these entities is known as chi-square test. So this way, this is the chi-square test where I can say O or FO is known as observed frequency, E or FE is known as expected frequency. Formula of calculating, because O is observed frequency, so this is we will collect from the data, but always you need to collect the E, that is the expected frequency, and this is the formula of calculating the E, that is the total observations divided by number of observations. So one thing is that you can see the two formulae I have written here for E. One is this, second is this. So what is the why I have written here two different formula to calculate E? Because the reason is there are two types of chi-square test: one sample chi-square test and two sample chi-square test. I think previously we have only heard about the chi-square test, or I can say we have heard about one sample t-test and two sample t-test. But for chi-square test also we can say one sample chi-square test and two sample chi-square test. So if we are having one sample chi-square test, or if we are going for the one sample chi-square test, in that case we can use this particular formula to calculate the E. And for the two sample chi-square test, this would be the formula of calculating E, where RT is the row total, CT is the column total, and GT is the grand total. So friends, this way we can calculate the chi-square value. In the table format, you can see if you have observed frequency, you have calculated expected frequency. That way you can take the difference, you can find the square of the difference, and then you can divide that square of the difference by the expected frequency, and when you will sum the last column, you will get the value of chi-square. So in the manual calculation, the thumb rule of accepting or rejecting the hypothesis is when the chi-square calculated value is less than chi-square tabulated value, then we are accepting the null hypothesis. So chi-square tabulated or tabulated value is also known as the critical value. So when we are comparing the critical value with the calculated value, and we are finding that the calculated value is less than critical value, in that case we can accept the null hypothesis. You can see this is the table which I am showing you if we are going for the manual calculation of chi-square. So in that case, how we'll get the tabulated value or critical value? You can find with the help of this type of table. where you need to have two things. First thing is the level of significance, and second thing is the degrees of freedom. So level of significance is the percent which we are fixing. Uh, in the social science, generally we are fixing the alpha value or level of significance value as 5%. That means we are taking the chance of committing type 1 error. That means if the null hypothesis is true and we are rejecting, or our data is not supporting it, so that means we are rejecting the null hypothesis. So when hypothesis is true and we are rejecting it, that means we are committing an error, and this error is known as type 1 error. So to committing the type 1 error, we are fixing as suppose 5%. And degrees of freedom depending upon your sample size. Generally, the formula for degrees of freedom is n-1 if n is the sample size. So that way you can calculate this, and the intersection point of your degrees of freedom and the level of significance will give you the value of tabulated chi-square or critical chi-square that you can compare and can make your decision whether you are going with the chi-square test or whether you are not going with the chi-square test null hypothesis. Now, as I just said, there are two types of chi-square test, one sample and the two sample. So here, firstly, I am discussing the one sample chi-square test. So one sample chi-square test is also known as goodness of fit test. So chi-square goodness of fit test is a non-parametric test that is used to find out how the observed value of a given phenomenon is significantly different from the expected value. So in this test, you only have one variable from a single population or one single source. So that way we will have the value of the one variable, and what we are interested in finding, whatever values or whatever frequencies of the variable we are having, we will compare those with the expected frequency, and thus we will calculate the chi-square, and then we will conclude whether the observed frequencies are equal to expected frequency or not. So null hypothesis for the one sample chi-square test or the goodness of fit is, in this particular test, null hypothesis assumes that there is no significant difference between observed and expected value or frequencies. Alternatively, we can say there is a significant difference between observed and expected frequencies or values. So this way, this will be the hypothesis for the one sample chi-square test. So I think, am I clear till this particular slide, or any doubt till here?
No, ma'am.
Okay, thank you. Now talking about the second type of chi-square test. So second type of chi-square test is two sample chi-square test. It is also known as test of association. Maybe you have heard about independent chi-square independent test of association, or chi-square independent of association name you have heard about maybe in your research journey. So here I can say this test can be used when categorical data for two independent variables are available with us, and we want to see if there is any association between them or not. So for example, we can say that gender performance on the driving test. So here we have two categorical variables. First is gender. The label in the gender variable would be male and female, and the driving test outcome can be the pass and fail. So we are interested to know whether the driving test is dependent on gender or not. So for this type of data, or for these type of variables, categorical variables, and when we are interested to find association in these two variables, we can go for the two sample chi-square test. Now, how we can apply chi-square test in SPSS? So there are two ways you can see here. One is we can go to the analyze, then descriptive statistics, and then we can go to the cross steps. Second way is we can go to the analyze, non-parametric test, then legacy dialogues, and then we can select upon chi-square test. So if the rule of, or if the assumption of chi-square test is violated, that means if at least in 20% of the sales of the expected count is less than 5. Means if in the more what I can say, if in more than 20% of the cells the expected count is less than 5, that means this particular rule or assumption is violated by the data. So in that case we will not go for the chi-square test. So in that case we will go for the Fisher's exact test. So this would be the alternative for the chi-square test. When the assumptions of chi-square test are violated, we will go for the Fisher's exact test. So I think how I will apply all these things, I am moving in the SPSS window to tell you these things. Can anyone confirm me whether the Word file is visible to everyone or not?
Yes, ma'am.
Yeah. So here I am showing you one case study. It is visible. One para is visible.
Yes, ma'am.
Yes. So I am expecting to every one of you, please read this case. This is a small case. On the basis of this, we will see the chi-square test. I'm giving you 2 minutes. Right? Yes, ma'am.
Yes, ma'am.
Okay. So I'm showing you further till here. So group 1 not provided with the vaccine, that is unvaccinated. We can call it as a control group, and the sample size of this group is 92. Second group provided with the vaccine and vaccinated experimental group, and the sample size is again 92. So you can see health outcome: sick with pneumococcal pneumonia, unvaccinated 23, vaccinated 5. Sick with non-pneumococcal pneumonia, unvaccinated 8, vaccinated 10. No pneumonia, unvaccinated 61, vaccinated 77. So this is the data given to us, and the same Excel sheet I have provided you also. I think you have received that in your group. So we will work on that particular data. So here the first question comes, because whenever we are going for the hypothesis testing, can anyone tell me, and are you knowing what is the procedure of hypothesis testing? Yes? Any one of you know what is the procedure of hypothesis testing?
Ma'am, if null hypothesis is rejected, then it is right, I think.
Okay. Okay. Ma'am, may I know your name, because I am on other screen, so I cannot see who is interacting with me.
Yeah, Shilpa, ma'am.
Shilpa, ma'am. Okay, ma'am. Anyone else?
Ma'am, I think we should check the level of significance to accept or reject the hypothesis.
Again, I'm repeating my question. My question was that, can any one of you tell me what is the procedure of hypothesis testing?
Ma'am, first we need to create this null hypothesis and the alternative hypothesis.
Very good. Ma'am, may I know
Yeah,
your
this
name?
side, Dr. Abba Kalaya.
Thank you, ma'am. So firstly, we need to create the null and alternate hypothesis. I can say alternate we are representing by generally H1 or HA, and null hypothesis we are representing by H0 or H0. Right. Now, second step is we need to decide upon the level of significance. That means what is the chance or what is the percent of committing type 1 error that we need to set here. Then we need to go for the selection of appropriate test. Then we need to decide, or we need to, what I can say, what I can write, I think I can write decide the or decision criteria. I think that is the correct word, decision criteria, or I can write state the decision criteria. So we need to write, or we need to decide upon what is the decision criteria, and then we need to apply selected statistical test and interpret the results. This is the process of the hypothesis testing. So as we all have read the case, from the case also we have got the idea about the variable. So we have three type of health outcomes. These are the outcomes listed here, and these are the number of employees who are vaccinated or not vaccinated. This is the data of that. So that way you can see when you will calculate this, in both the groups you will find 92 and 92 employees. So that way we have total 184 employees data. So for this, firstly, we need to state the null hypothesis. So now any one of you can tell me what is the, or what I can make as a hypothesis of this. Can anyone tell me for this data, what hypothesis I can create or write? Anyone will try?
Madam, vaccination affects the disease.
Vaccination affects the disease. Okay. Okay. Anyone else?
There's no relationship between vaccination and the occurrence of pneumonia.
Okay. Okay. Good. Or koi? Anyone else?
There is a significant relationship between vaccination and pneumonia.
Okay. Okay. Good. Anyone else?
HO maybe, ma'am, there is a no significance relationship between pneumonia and this vaccination. And alternative, maybe there is a significance difference between these.
Yes. So I think you can see when clearly in the table, you can see we have clearly stated health outcome and the vaccination status. So I think many of you have said it correctly. I can write that there is no significant association between health outcome and vaccination status. So this would be our hypothesis for this particular case. Or alternatively, I can say health outcome is independent of vaccination rate or vaccination status. I think rather than rate, it should be status. So I think, is it clear? Null hypothesis is clear to everyone?
Yes, ma'am.
Can other people also say something whether it is clear or not?
Yes, ma'am, it is clear.
Yes,
Okay.
clear.
Yeah, thank you so much, ma'am. So for this hypothesis, as we are interested in finding the association here, we are finding whether those two variables are independent to each other or not. I think with this we are understanding, because both the variables are categorical in nature. We have a nominal scale variable. What I can say when I say the health outcome, so that means I am categorizing the people who are sick with the pneumococcal pneumonia. This is the one category. Second category is sick with the non-pneumococcal pneumonia. This is the second, and the third category is no pneumonia. So so that way we have only done the classification. We cannot arrange them either in ascending order or in descending order. So that way we can say this is a nominal scale variable, and whether the people are vaccinated or not. So yes or no type of answer will come. So again, it is a dichotomous scale question or binary type of question. So that way we can say both the variables we have are categorical in nature. So for those two variables, we'll go to formulate this kind of hypothesis, and then we will go in SPSS to test that particular hypothesis. So I think now can I go in SPSS? Yes?
Yes.
Yeah.
Okay.
Yeah, thank you so much. Now I think, can anyone tell me what was the procedure I have discussed yesterday to import the data in SPSS? Because I think I have shared an Excel sheet with all of you deliberately.
Yes, ma'am.
So how I can import a file here? Sorry to say, but I think
Ma'am, go to a file, then import data.
okay.
Yes.
Then
You can directly go to
Go to the file menu.
cell.
this is the one way. I think one more person is saying something.
Oh, yes, ma'am.
Yeah, thank you, ma'am. You are correct. Second, ma'am. Yes, ma'am. File. Then after this, open. Yes, correct. Thank you. Then
Open.
then data. And then wherever your file is situated, you need to give the location of your file. And then you need to select the extension of your file. It is Excel. So now from this, I am picking the case study data and I am clicking on only open. So it is asking me about the range and everything. We are fine with this. You need to only click on OK to open the data set here. So I think I am here with the data. Is it visible to each and everyone or not?
Yes, ma'am.
Yeah. So now it is up to us. Just a minute. It is up to us. Firstly, I think I can check the frequencies. So I'll go to the analyze menu. Then I'm going to descriptive statistics, because what I want to do here, I want to write the values. I want to define the values for my these two variables. As you can go in your variable view and you can see values are not defined here. So I want to define those values there. So for that, I am not knowing how many zeros are there, how many ones are there. So for that, I am going here in analyze menu and I'm clicking on the descriptives and then clicking on the frequencies. Then I am selecting both the variables, shifting them to the variables box, and then I'm because I only want to calculate the frequency, so I'm not clicking on anything else. You can see here display frequencies. Frequency tables is the checked here. This particular box is by default checked by the SPSS, so you only need to click on OK. So that way you can find these are the frequencies. Done? Is it clear? How to apply frequencies? Is it clear to everyone? Do I need to repeat it again? I'm not getting any answer. Can anyone tell me?
No, ma'am.
Is it clear, ma'am?
Yes.
Okay, thank you so much, ma'am. So now you can see I have a data this.
Yes, ma'am, it is
I
clear.
am coming to the output window. Yes. I think it is not giving me the cross-sectional type of frequency. Just a minute, I'm going to the. So I think rather than doing this, I'm directly going in the analyze menu. You can go to the descriptive statistics and then you can select the cross steps. Again, I'm repeating, go to the analyze menu, then select descriptive statistics. Then in the further parallel box, you can select the cross tabs. I'm clicking on this. So the cross tabs button is coming, or the box is coming in front of us. Now you need to shift one variable in row and second variable in column. So I am selecting my first variable, health outcome, in the row and vaccination status in the column. This way it will give us the cross tabulation also, and it will also give us the value of chi-square. So you can select the health outcome variable and shift it to the rows box, and the vaccination status variable into the columns box. It is done. Is it done?
Yes, ma'am.
Now you can click on exit. You can see by default option is asymptotic only. So we are okay with it. You can only press here continue, and then you can go to the next button or next step, that is the statistics. From here, you can firstly click on the chi-square box. Done. Everyone is with me, those who are performing. My pace is okay today? Yeah.
Yes,
So
ma'am.
you can click on chi-square, then you can press continue. Then you can go to the cells. From here, you can see observed is by default checked by SPSS under the count set. You can also click on expected. And apart from observed and expected, you do not need to calculate anything else here to get the results of chi-square. So you can directly press here continue, and rest of the things are all okay. You can only press here OK to generate the output. So my output is generated. I hope everyone has got the output, those who are performing. Done. Everyone is ready with the output? Yes. Shall I go for the interpretation part?
Yes, ma'am.
Yes. Thank you, sir. So here you can see,
Yes, ma'am.
thank you, sir. So here you can see case processing summary. So we are trying to find the cross tabulation of these two variables, health outcomes versus vaccination status. So in these two, total sample size is 184, and nothing is missing value in the data. So that's why whatever is the valid percent or valid sample size, similarly same is coming in the total column also. Moving to the next table, that is health outcome versus vaccination status cross tabulation. So here you can find first thing, count for the 0, that is not vaccinated, and 1 are vaccinated. So that way, how many of them are not vaccinated? 23, and 1 is vaccinated under the first category. Second you can see now expected count is calculated by SPSS only. We have not calculated because SPSS will take care of this, and it will, on the basis of our observed frequency, it will give us the expected count or the expected frequency. So we are getting these expected frequency. So now for all three categories, we are having count, that is observed frequency, and we have expected count, that is the observed frequencies we have. Now, after that, I'm moving to the main table of the chi-square, and here you can see at the end of the third table, the assumption, second assumption of chi-square is mentioned. Here you can see 0 cells have expected count less than 5. Means we were permitted to 20%, if in 20% cell expected count is less than 5. Just a minute. Ma'am, I'll talk to you later. I am in a workshop. Yeah. So you can see here it is written 0% or 0 cells have expected count less than 5. But according to assumptions, we were permitted for 20%. But here, according to this, no cell is carrying less than 5 frequency, or no cell or no expected cell is carrying less than 5 frequency. So you can check here. In the first cell, expected count is 14, which is more than 5. In the second cell also, expected count is more than 5. Then in the Next cell, you can see expected count more than 5, expected count more than 5, expected count more than 5, and in the last also expected count is more than 5. So thus, in all the cells, expected frequency is greater than 5. So that means this particular data is not violating the assumption of chi-square test. So, sir, the person, that participant who has asked me the question, sir, can you tell me, is it clear now?
Yes, ma'am, it's
Yeah,
clear.
thank you so much, sir. So now you can see that means the first assumption was that we have collected the data from one respondent only once. So that we have done for this particular data, we have collected the data from the one respondent at a first time or at once only. So that we have done, that we have taken care. Second assumption here, we can check from the output of the chi-square test only. So that also we have checked. So that means we are okay, or we have found this thing that all the assumptions of chi-square test are met. So that's why we can report here the value of chi-square. So you can see Pearson's chi-square value is 13.649 for the 2 degrees of freedom, and its significant level is the 0.001. So can any one of you tell me, this is the p-value for the chi-square test. So now on the basis of this, what I can conclude, whether we are going to accept the hypothesis or reject?
Reject the hypothesis.
We will reject the null hypothesis. Yes, thank you so much, ma'am. It's correct. So I'll tell you how you can write your results. So here I have already written, you can see, we can write at 5% level of significance, and for 2 degrees of freedom, chi-square is 13.649 and p is less than 0.05. So we do not have enough evidences to support the null hypothesis. Thus, we can conclude that there is a significant association between health outcome and vaccination status. So I think, am I clear on this part?
Yes, sir.
If you want to note down the interpretation part, I suggest you please note down. Try to write so that you would be able to understand how we can write the interpretation part of chi-square test. So may I switch to the next window, or do I need to stay on the same? Anyone who is noting it down or capturing it?
Ma'am, I captured it.
Okay, thank you, ma'am. So I think now we are done with the 2 samples chi-square test. So any question or any query so far for this particular part?
Madam, please explain p value or significance value, why it is 0.1 to 0.00.
Output you are talking about?
Explain the significance value 0.5 or 0.1. Why we note at 0.5 only?
Okay, just a minute. I need to check. I think if it is in some of the tests, generally in SPSS, it is given to us that the particular hypothesis is tested by SPSS at 95% or 99%. So in case of the chi-square test, you can see I have checked each and every button. It is not mentioned. So by default, we are assuming generally in SPSS, most of the tests are tested at 5% level of significance. So that's why if the level, just a minute, I'm going to the Word file. So if we have set level of significance 5%, that means we are taking a risk to reject a true null hypothesis. So the risk is of 5% only when the hypothesis will be true and we are going to reject it. That chance is only 5%. We are saying this thing, that there is only 5% chance that when the hypothesis is true and we are rejecting it. So 5% meaning is what? It is 0.05, right, ma'am?
Yes, ma'am.
So if we are setting this value as 5%, so whatever significant value or p value we are drawing from the output of SPSS, you need to compare always that p value with this level of significance. So our p value was our p value was 0.001. So when we will compare this 0.001 with 0.05, I think you can see here, we can say this thing that 0.001 is less than 0.05, right, ma'am?
Okay, madam.
So, ma'am, usually this is not, this means this is not, we can understand this thing, but in the writing term, we need to write like this. Okay, that p value is less than 0.05. Is it clear now, ma'am?
Yes, ma'am.
If suppose you are setting, suppose you have set here 1%, that means you are very much confident that your data will not reject the null hypothesis when it is true. So that means we have set the label of significance at 1%. So that means in that case, you will compare your p-value from this. So that way here you need to write this. Is it clear now?
Yes, madam.
Ma'am, does it mean, ma'am, sorry to interrupt,
Yes, sir,
does
please.
it mean that when we keep this confidence interval at 95%, does it mean that keeping the p value at 0.05%, does it mean that
Yes.
our data 95% of our data is correspondence with the alternate hypothesis? That 95% of the data that we have collected correspondence to that only.
It is 1 minus alpha, right, sir? That means
Okay.
here label of significance is known as alpha.
Alpha.
So that means confidence level would be 1 minus alpha. So if we have set it as suppose 5%, so that means this would be your 95%.
Yes, ma'am.
That means we are 95% confident that our data will not reject the null hypothesis when it is true. Is it fine, sir?
Yes, ma'am. Thank you.
Okay. Thank you, sir. Anything else anyone wants to ask me? Okay. So I think I can move for the next test now.
Yes,
So,
ma'am.
yeah, thank you so much, ma'am. So, I think one more sheet, I think that is the .sav type of file of this is the SPSS file I have shared with this, sir. I hope you have got that file. This is the candy colors file. Are you getting it or not? I think I forgot I have shared or not. Have you got the second file also? Can anyone confirm me?
No, ma'am. We have just received one file.
Okay, so give me a second only. Ajay sir, are you there in meeting? Can anyone is there to whom I can share the file?
Yes, ma'am.
Renuka, ma'am?
Ma'am, you can, you're there in the WhatsApp group, ma'am.
No, ma'am, I'm not there.
Okay. So, ma'am, you can share in the editor's book chapter. I will share it, ma'am, from there.
Okay.
Or experts group is there, no? You can share it.
In this?
Hi, yes, ma'am.
Okay.
I'll share the file in the FDP program group.
Okay, fine, ma'am.
Yes, ma'am. Thank you, ma'am.
Welcome, ma'am. It's Renuka, ma'am, right? I think I cannot see who is talking
Yes,
to me.
ma'am. Yes, ma'am.
Yes,
It's
yes, yes, yeah. Renuka, ma'am, I have shared this that particular file with you in that particular group. Please share with the participants. It is done. Renuka, ma'am, it is done.
Ma'am, I think I'm not there in the group. You can share the file in officers group, ma'am. RFI officers group is there, no? Yes, ma'am.
Okay, I have closed the WhatsApp window. Sorry. Again, I'm opening it. In which group, ma'am?
RFI officers group, ma'am.
I think I'm not there.
Oh.
Sir, will you ping me on the, I think I have shared with you. So will you ping me on WhatsApp? I think I am not able to find your
Yeah,
number.
ma'am, I'll share the file, ma'am. I got it. I'll share it.
Okay. Sir, I have shared with you.
Yes, yes, ma'am. I got it. I'll share it, ma'am.
Okay, ma'am. Thank you.
Thank you. Participants, I've shared the file in the group. You can check it from there.
I hope everyone has received it. I request you to please
Yes.
download it and open it so that we can work on that.
Can anyone confirm whether you got the file or not?
Yes, ma'am.
Okay,
Okay.
ma'am.
Thank you, Ranika, ma'am.
Welcome, ma'am.
So everyone, please download the file and open it. It is a .sav file, so I think you do not need to import it. Do not need to import it in the SPSS. You can directly open it in the SPSS form only. So I think it is open. May I proceed now? Now I'll go. Now I'm going to discuss the one sample chi-square test. So can I go now?
Yes, ma'am.
Okay, ma'am. I'm coming to my, yeah. So here again, I am just elaborating you the case. Suppose I think you all have heard about the Candy Crush game, right? It's a game on mobile. It's a Candy Crush game. So maybe you have
Yes,
heard about
ma'am.
this game. Yeah. So this case is based on that only. Suppose now company wants to know the interest of the players of the game, that which colors candy they want to see. So for that, what they did, they have done one survey, and then you can see in the variable view I'm showing, they have given the choices of 5 colors: blue, pink, green, brown and yellow to the to the players, and that way they have collected how many of them are going with the blue color candies, how many of them are going with the pink or green or brown or yellow colors candy. So that way they want to collect the data for that, and further they want to check whether whatever is the observed frequencies or whatever is the collected data, whether that data is different from the expected or not. Because in the one sample chi-square test, generally we are expecting the equal distribution of the frequencies along all the categories of the variable. So here in the color variable we have 5 labels, 1 2 3 4 5, or these are the representation of the 5 colors. So generally, the company manufacturing or the company who has developed that particular game, they are generally assuming that the for each colors there are equal frequencies they will get. That is their expectation. So that way, whatever color candies they want to launch, they can. But then after that, when they have collected the data, so they have collected collected the data in this form. So you can see for one, that is the blue color, observed frequency was the 25. For the second color, that is pink, I think observed frequency was the 20. For green also 20. Then for the remaining two colors, it was 15 and then 20. So that way, these were the frequencies they have collected. So for this particular data, now can anyone tell me what would be the what I can say? What would be the hypothesis, null hypothesis? Yes, anyone?
The hypothesis for is there is no significant relationship between health and vaccination status.
I think, ma'am, I was talking about now. I was talking about the second case now, Candy Crush case.
Ma'am, it is not displayed on the screen.
Okay, is it? Can anyone confirm me my screen is visible or not?
It's visible, ma'am.
Okay. So, ma'am, you need to find out whether my screen is pinned or not at your place. If you need to pin my screen. So, may I proceed?
Yes, ma'am.
Yeah. There is no significant difference in observed and
Frequency and color.
yes, expected frequencies of candy colors. Right? Yes or no?
Yes, ma'am. Yes, ma'am.
Yes. So this would be our hypothesis that there is no significant difference in observed and expected frequencies of candy colors. Alternatively, I can say there is a significant difference in observed frequencies and expected frequencies for candy colors. I think rather than of, we should write there for. Done?
Yes, ma'am.
Yeah, thank you, ma'am. So now I am moving to the SPSS file. Now you can see here we have three columns. First two I have clearly explained you. This is the color 1, 2, 3, 4, 5, and these are the frequencies of the color. One more way of writing this data you can see I have written here, because 1 is 25 times, 2 is 20 times. So that way I have written our data in that form also. 25, one I have written 25 times, 2 I have written 20 times, and likewise for the remaining numbers I have written those numbers as per their frequencies. So that means this data can also be written in this form. Is it clear to everyone?
Yes, ma'am.
So now firstly I'll tell you for these two things that what I think, rather than talking about these two, firstly I'll tell you this particular column usage in the chi-square test, because when I'll tell you the, I think, weighing of the case, I need to tell you for the second type of data, for this type of data. So firstly what I can say, I'm considering the color one data firstly. So for applying the one sample chi-square test, you need to go to the analyze menu. Then you need to go to the non-parametric test category. And then from here, you need to go to the legacy dialogues. And then you need to select chi-square. So remember, in the previous form, in the two sample chi-square test, we went on the analyze and then descriptives. And then we have selected cross tabs. But for the one sample chi-square test, you need to go to the analyze menu, then non-parametric test, then legacy dialogues, and then chi-square. Is it clear to everyone? May I click on chi-square now?
Yes, ma'am.
Yeah.
Yes, madam.
So once I have clicked on this, you can see, firstly, I'm resetting it. Yeah. So firstly, I'm going with this color one. Now I'm shifting this particular variable into the test variable list box. And then I'm clicking on the exact button. Here you can find by default option is asymptotic only. So we will go with it. And then I'm pressing on continue. Now I'm talking about the remaining two boxes at the lower side. You can see the left box is the left box is titled as expected range. So expected range of the data by default option get from the data. Second is use specified range. So for the expected count or for the expected frequency, SPSS is giving us two options, whether we want to get the expected frequency from the data only, or whether we want to specify any particular range for getting the expected frequency. So by default option is get from the data only. So I think we should always go with this. According to data, we will get the expected frequencies. So we are going with the get from the data only. Talking about to the right side box, which is situated at the lower right corner, you can see it is written expected values. All categories equal, and it is second giving me if I want to specify the expected value here. So here it is asking me to give any range, and here it is asking us for all categories we want to keep it equal, or if we want to specify any particular value, that also we can do here. So we will go with the by default option, either it is a expected range or whether it is a expected value. So for both the things, we are going with the by default option of SPSS, and then you need to only click on OK to generate the output. So I hope output window is visible to each and everyone.
Yes, ma'am.
Yes. So now you can see here, these are the colors which were named as 1, 2, 3, 4, 5, blue, pink, green, brown, and yellow. These were the expected frequencies, these were the observed frequencies or observed count, and these are the expected frequencies calculated by SPSS. And these are the, at the third column, you can find the residuals. Residuals means the difference between the observed and expected is the residual. Now, on the basis of this data, you can find that chi-square value is calculated and it is 2.5. Its degrees of freedom would be 4, because for what I can say, again, for the degrees of freedom, formula is n-1. So we have 5 categories, 5 minus 1, 4 will be the degrees of freedom. Then the significant value is 0.645. So can anyone tell me, if we are testing this hypothesis at 5% level of significance, so on the basis of this significant value, whether we are going to accept the hypothesis or reject the hypothesis?
No, we will accept the null hypothesis.
Yes. Thank you, sir. So that means we can conclude that there is no significant difference in observed and expected count or frequencies for these different colors candies, right? So this was the assumptions. This was the interpretation of this particular table. Talking about the assumption, so you can see assumption is again saying the same thing, that in the 0 cells or in the 0% sales, the expected count is less than 5. So means all the cell have expected count value greater than 5. So that way, again, there is no violation of the rule of chi-square or assumption of chi-square test. So this is about the one sample chi-square test. So I think am I clear on this? May I go for the second type now?
Yes, ma'am.
Yeah. So again, I'm coming back to my file, and now if rather than, this is the one way of the presentation of your data. Now rather than this, if suppose data is in this particular form, we have 5 categories of color, and along with that we have given here the frequencies also. So in that case, if I am going to apply chi-square test, what I need to do here, that I'll show you here. Again, I'm using this shortcut or the shortcut handle, which will lead us to the chi-square test directly. So I'm clicking here on chi-square test. Now I am shifting this color one to the back to the left box, selecting here the frequencies and shifting it to the test variable list. Now everything is all set here. You do not need to click anything here except clicking on OK to generate the output. Output is generated by me. I hope those who are doing along with me, they are also getting the output. Yes. Okay. So I think I have heard yes from one of the participant. I can say that yes, you have got the output. Now you can compare because data is similar. I'll show you one more thing here. You can see these are the observed frequencies for all the 5 color candies. And these are the expected count by the SPSS. But here, when we have applied the chi-square test with the help of that kind of data, or with the help of the representation of the data in that particular form, so that way you can see here, it is only giving you 3 categories, 15, 20 and 25. These are the observed frequencies, these are the expected frequencies, and this is the chi-square value. So now I think we can see the chi-square value is 1.6 here, and in the previous data or in the previous table, you can see chi-square value was the 2.5. That means there is some problem with that particular thing. Is it or not? I think everyone is catching this thing. There is problem, right? Can anyone confirm me? Am I audible? Are you with me?
Yes, ma'am.
Okay. So I think if you are finding that there is a problem in the data, so what is the problem that we will see here, that how we can do that particular thing or how we can fix this particular problem in the SPSS. So for that, you need to weigh the case, how you will do that particular process. For that, you need to go to the data menu, and from here you need to pick the last option, weight cases. Again, I'm repeating, go to the data menu and select weight cases. Click on this, and here you can see by default option, do not weight cases, but we want to weight cases. So I'm clicking here on the weight cases by, it is asking me to shift the frequency variable. So my frequency variable is this. I need to shift this variable here in the frequency variable box. Apart from shifting the variable, you do not need to do anything except clicking on OK to weighing the case. Now when I'll press on OK, you can see the output window of SPSS is giving me the message that weight by frequency. That means weighting of the colors are now done by the frequency. Now again I'm going to the chi-square test box, shifting here my, I think it is all set although, but again I'm picking the frequency and shifting it to the test variable list, and then I'm clicking on OK. So that way you can just a minute. There is some problem. Yeah, I have made a problem. Extremely sorry for this. Now you need to shift your color box, color variable in the test variable box, because we have weight this color categories with the frequencies. So you need to shift this weight, this color here, and then you need to press on OK. So that way you can see we are getting the same output as we have applied on the third column, that is color 1. So here again I am getting the chi-square value as 2.5, and you can see these are the observed frequencies and these are the expected frequencies. And again when the results are similar, so we can conclude this thing that according to the p-value or significant value, I can say this thing that the null hypothesis does not hold, the null hypothesis we are accepting, and we are concluding that there is no significant difference in the observed and expected frequencies for the candy colors. So this way, this is the one sample t-test in one sample chi-square test in SPSS. So till here, I think, am I clear to everyone? Any doubt? Anything I need to repeat? Today, I think I'm not getting any answers.
Clear, ma'am.
Okay, so no doubt.
No, ma'am.
Okay, so I am just giving you a recap of the session. Today, we have discussed on the, or we have discussed about the non-parametric test. We have seen the conditions that when we will go for the non-parametric test. So in that we have seen we should have the categorical scale variable. We should have the variable which maybe means in case I can say when the variable is measured on the continuous scale, but they are not following the assumptions of parametric test. In that case also we can go for the non-parametric test. So these were the certain things which we need to help out to understand when we need to go for the non-parametric test. Then we have seen about the chi-square test. So chi-square test, in chi-square test, I have explained you that whenever we have categorical scale variable and when we are interested to find the association or relationship between the two categorical variable, in that case, the appropriate test is generally chi-square test. Then I explained you today that there is two types of chi-square test, one sample and two sample. In one sample, we will have only the values or frequencies for the one variable, and we are expecting whatever is the categories or levels of that variable. In those categories, the expected count will be equally distributed. Then we have discussed the second test, that is the two sample chi-square test. In that, I have explained you that we will have two categorical variable and we want to find the association between those two variables, and then we want to or we will arrange the data in the contingency form, or with the help of cross tabulation we will get that contingency table, and then we will see what is the chi-square value. Along with the chi-square table, we will also get the second assumption of chi-square test, that whether how many percent of the expected cells are less than 5 or greater than 5. So with the help of that, we will firstly check the assumption of chi-square test, and if it is not violated, then we will go with the chi-square test, or and again with this we will report the p-value and we will compare that p-value with the level of significance. So that way we will conclude whether we are accepting or rejecting the null hypothesis. So this was the whole story of the day from my side. If you have any queries regarding whatever I had discussed, or if you have any other query, you can ask me. The forum is open for all of you now.
Participants can ask their doubts.
Any query from your side, participants, please interact.
Ma'am, I think there are no doubts.
Maybe. I think even I am not getting any of the responses. So maybe there is no doubt. We are assuming this thing. So thank you all. Yeah. So thank you all. Your patient listening to me. I think I have tried to do justice with the topic for the day. Tomorrow we will meet with the another topic of I think from the parametric test category, and then we will see how we can apply non-parametric test using SPSS. This is all for the day from my side. Over to you, Ranuka ma'am.
Thank you, ma'am.
Yes, ma'am. Thank you so much for the extensive lecture on chi-square test. It was really very good, and you gave a lot of examples, what are the types and everything. It was so clear to everyone. And I thank all the participants for their enthusiastic participation. Thank you all, and we'll meet tomorrow at the same time for day 4 session. Thank you, ma'am. Thank you, participants.
Thank you so much, ma'am. Thank you everyone for attending this session and listening
Excuse me, ma'am.
patiently. Yes, Jagriti ma'am.
मैम मैम आपने बहुत अच्छा ही पढ़ाया है और आप पूरे टॉपिक को बहुत अच्छा जस्टिस भी कियो। वो क्या है कि हम लोगों को बहुत इजीली जल्दी समझने में थोड़ा दिक्कत होता है ना, इसीलिए आपको रिस्पॉन्स नहीं कर पाते। मेरा तो ये सेकंड FDP है। मैंने जो आपको मतलब मैं सुन रही हूँ, एक 3 to 5 वाले टाइमिंग में भी मैंने अटेंड किया था, तो वो मैं अच्छे से सुन नहीं पाई थी, बट ये वाला तो मतलब समझ में आ रहा है, लेकिन सडनली रिस्पॉन्स करने में ऐसे टेंशन रहता है, आप कुछ क्वेश्चन पूछ दोगे और जवाब नहीं दे पाए तो करके ना। बहुत अच्छा पढ़ा।
Jagriti ma'am, listen to me. I think this is the platform where we are all are learning. It is not like I am expert. I think I am also a learner like you people. I am also learning from your queries. तो आप ये मत सोचिएगा कि मैं कुछ पूछ लूंगी या कुछ कर लूंगी. Thing is that अगर आप पूछेंगे, so that way maybe I'll explore more. एंड अगर मैं आपको आंसर दूंगी तो आप भी आपका नॉलेज इंक्रीज करेंगे और मेरे भी नॉलेज में इंक्रीमेंट होगा. सो डू नॉट हेजिटेट इन आस्किंग क्वेश्चंस.
जी मैम, जी बिल्कुल. थैंक यू मैम.
Thank you, Jagriti ma'am, for your feedback. Thank you so much. And thank you for attending second time also. Yes, Juma ma'am.
Very nice explanation, ma'am.
Thank you so much, ma'am.
Thank
Ma'am,
you. Thank you.
from where are you, ma'am? Juma, ma'am?
Yes, I am from Assam, Guwahati.
Oh my God, very far. Yeah. Thank you so
Yes.
much for joining. Thank you.
Thank you to you too for explaining it in such a nice manner.
I try my best, ma'am, but it happens sometimes. Maybe we are unable to do justice with the things, but I try my best so that I can communicate the things to the persons, those who are attending the workshop. I try my best.
Thank you, ma'am, for your valuable time.
Thank you. Thank you so much, Juma, ma'am. Anything else, participants? Or can we wind up now? Yeah.
Yes, ma'am.
Thank you,
I
sir.
think we can wind up. Thank you,
Yeah.
participants, for your valuable feedback. Thank you, ma'am.
ma'am. Thank you so much, Renuka, ma'am. Thank you.